Have you ever wondered how pollsters can predict a huge election before anyone's even voted? Or how a company knows a battery will last for thousands of hours without, testing every single one? It feels kind of like magic, right? Well, it's not magic. It's a really powerful statistical secret, and today we're going to pull back the curtain. It's all about a smart shortcut called sampling, and believe me, it shapes our world in ways you probably don't even realize. So, here's how we're going to break it all down. We'll start with that seemingly impossible question. Then, we'll unpack the solution by looking at what a population is versus a sample. After that, we'll dive into why fairness is absolutely crucial, why size definitely matters, and finally, we'll see how this whole thing plays out in the real world. All right, let's jump in.
First up, the impossible question. Let's frame this whole idea with a challenge that, on the surface, just seems completely unsolvable.
Okay, seriously, think about a big election. You see the news reports, and they're confidently predicting a winner, sometimes weeks ahead of time. But wait a minute. They haven't talked to the millions upon millions of voters out there. So how on earth do they know? What's their secret? Or, get this. A factory makes millions of batteries, and they print right there on the package, lasts up to 40 hours. But if they actually tested every battery for 40 hours until it died, they'd have nothing left to sell. Just a giant warehouse full of dead batteries. So how can they make that promise? Well, the answer to both of these puzzles is actually the same, and it's pretty brilliant. They don't try to measure the whole massive, messy group. Instead, they use a clever little shortcut to get a surprisingly accurate picture of the whole thing, and that shortcut is exactly what we're here to talk about. Which brings us to our next part, population versus sample. This right here is the heart of the whole idea. To really get this shortcut, you've got to understand these two key terms. Getting the difference between them, that's the key to everything. So first, let's talk population. And no, we're not just talking about the number of people in a country. In statistics, the population is the entire group you want to know something about. It could be all the voters, every single battery off the line, or, and this is a great analogy we'll keep using, the entire pot of soup you just cooked. It's the whole shebang. Now, you're not going to eat the entire pot of soup just to see if it needs more salt, right? Of course not. What do? You take a sample. A sample is just a small, manageable piece of that big population that you actually look at. It's the spoonful you taste to figure out what the entire pot is like. And there it is. That's the big distinction. The population is the whole thing we're curious about. The sample is the small piece we actually check out to understand it. Sounds simple enough, right? But there's a pretty big catch. And that catch brings us to section 3, the importance of fairness. This is where it gets really interesting, because you can't just grab any old spoonful. To get a true taste of the soup, your sample has to be chosen in a very specific and very fair way. I mean, think about it. If you just sprinkled some parsley on top of the soup and you only take your spoonful from the very top, you're going to get a mouthful of parsley and think the whole pot is a parsley bomb. That's a biased sample. To know what it really tastes like, you got to give it a good stir, right? Get a spoonful that has a little bit of everything in it. This is the absolute core idea of fairness in stats. Just look at the spinner. For a game to be fair, every single section has to have an equal shot of being landed on. Well, a fair sample works the exact same way. Every single person or item in the entire population needs to have an equal chance of being picked. And there's a special name for this kind of perfect fair sample. It's called a representative sample. The goal is basically to create a mini-me of the entire population, a perfect, tiny copy that has all the same variety as the bigger group. This means we have to be super careful to avoid bias. For instance, if you want to know what the whole country thinks about a new movie, you can't just ask your friends. They probably like the same stuff you do. That's biased. Or if you're studying public transit, you can't just survey people at one fancy train station in the suburbs. These methods give you a totally warped picture of reality, all because they aren't fair. All right, on to section 4, why size matters. So we've got it. Our sample has to be fair. It has to be representative. But there's one more piece to the puzzle to make sure we're getting things right, the size of that sample. The basic principle here is really simple. The more times you do something, or the more people you include in your fair sample, the more you can trust your results. A bigger, well-chosen sample just gets you closer to the truth. Let's go back to our soup again. Tasting one tiny drop with an eyedropper, you might just get a drop of plain broth and miss all the good stuff. But taking a whole ladleful, Now you're getting a much richer, more accurate idea of how the whole pot tastes. As long as it's gathered fairly, more data means more confidence. So let's make this real. Imagine we have a spinner with some numbers on it. If we only spin it a few times, a really small sample, our average score might come out to something like, 3.5. But is that the real average? Probably not. Now, look what happens when we go big. We spin that thing hundreds, maybe thousands of times. Suddenly, our average score starts to settle down, getting much, much closer to the true average, which in this case is 3.1. That's the power of a large sample. It smooths out all the random flukes and gives us a result we can actually rely on. And that brings us to our last section, sampling in the real world. Okay, this has been a fun little trip through statistics, but why does any of this actually matter to you? Well, the thing is, this stuff isn't just in textbooks. It is happening all around you, shaping your world every single day. Every single time you see an election poll on the news, that's sampling. When a TV network cancels your favorite show because of the ratings, yep, that's sampling too. The quality checks on the phone in your hand, the medical trials for new medicines, the research that decides what new coffee flavor to launch, it is all powered by this one simple, powerful idea. So really, the big takeaway here isn't just about math. It's about empowerment. Once you get the basics, population, fairness, and size, you kind of gain a superpower. It's the ability to look at all the data and stats thrown at you every day and not just accept them, but to actually question them. Which leads us to one final thought. The next time you see a headline with some shocking number or a poll with a wild result, what's the first question that's going to pop into your head? If you find yourself thinking, hang on, how big was their sample? Or wait, was that sample even fair? Then congratulations. You're not just taking in data anymore. You're thinking like a statistician,